Hi, this is Jay from caldereriaonline.com. In this video, I'm going to show you how to unfold a rectangle to round transition with sharp corners, or better said, as sharp as they can get in real sheet metal bending. Truly sharp corners in sheet metal aren't physically possible. When we bend a sheet, one side gets compressed and the other side is stretched. When this internal bending radius is less than 5 times the sheet thickness, the neutral axis, where there is no tension and no compression stress, is no longer centered. It shifts toward the inner side. So bending causes stress, and with stronger metals and tighter bends, you risk getting cracks on the outside of the bend. For thin sheet metal, you've got two options. Use the minimal internal bending radius allowed by your material, and that's the sharpest corner you can get without risking cracks. Or tip number one, use an internal bending radius of 1.29 times the thickness and make notches or cuts at the corners so you relieve the bending stress if needed. This gives you a corner joint on a rectangle end. The actual bending should happen at a place where you already have an acceptable bending radius. In this case, bending or having a corner joint means the same developed length. I will draw a square to round transition using 1.29 times the thickness as an internal bending radius. So here I am in caldereriaonline.com. I will do this square to round transition using 1.29 as the internal bending radius. So this is 1.29. I am using internal dimensions. I will do this in two parts. I calculate the pattern and I will download this and I open in my CAD. So here I am in my CAD. I will open my last download. And as usual, we get the 3D representation and the 2D development. And this is the sharp corner we get. Now, about that 1.29 number, where does it come from? That's the value where if you consider the bending line as either a cut or a bend, the final part dimensions turn out the same. It's based on sheet metal bending formulas from standards like DAN 6935. To show this, I will draw a square duct in two ways. I'll input the same dimensions in a hopper pattern, calculate it, and download the DXF. Then I will do the same using the rectangle to rectangle pattern, entering the same internal dimensions and setting R equal to 1.29 of the thickness. So, tip number two, to create a duct on a hopper or transition dialog, just set all the offsets to 0. And tip number three, remember hopper dimensions are always internal. I will download both developments and compare their total developed lengths. So I will start with the hopper. So remember, we have internal dimensions are always internal for hoppers. We have the square 600 by 600 on top and bottom, and this is centered because of the offsets equal to 0. I calculate the pattern. This is very easy. I download the file and I will make the same with a rectangle to rectangle transition. So back here, I will pick this one. I will enter 600, 600. Being the thickness 1 millimeter, the internal radius will be 1.29. Offset 0. I will do this in one piece. Again, dimensions are internal, and being thickness 1 millimeter, the internal dimension for the bending radius is 1.29. I calculate the pattern. Again, it's very similar to the first one. I download this and I will open this too in my CAD. So back in my CAD, I will first open the hopper, and here it is. And I will also open the last download. I compare distances. 2,400 millimeters. 2,400 millimeters. There is a tiny difference that comes from the rounding of 1.29 value to 2 decimal places. And here we have a final tip. Tip number 4. If you are using the hopper pattern, you can either cut and weld the four sides as shown in the DXF, or bend them instead using the cut lines and bending lines, as long as you use a bending radius of 1.29 of the sheet thickness. Keep in mind your material still needs to allow the radius without cracking. That's it for today. I hope you find this video useful. Thanks for watching and see you next time on caldereriaonline.com. Have a great day.